Welcome to TTI. Welcome to the whole new world of science and robotics. Today, we are going to explore the incredible world of robotic sea creatures. So watch the entire video to discover something new and something robotic.
Number 10.
Most of us have probably eaten fish, and maybe have even had a pet goldfish. But few of us have seen a robotic fish. Fish is another underwater inhabitant, which help us detect water contamination. But guys, do you ever think how to control the level of water pollution? You can take samples and analyze it in the laboratory, or you can do it the smart way by using a specifically designed robot in the form of a fish that will float in the water and be capable of checking the water's purity. The University of Essex has developed a robot fish in order to fulfill water monitoring needs. There's plenty of components packed inside of the fish, such as pressure sensors to actually detect what level of water it's in. Other applications include seabed exploration for resources, or rescue jobs, or for the underwater oil leaking pipe leakage detection, and telecommunications cable detection as well. Thankfully, this fish is keeping us safe by keeping our water safe.
Number 9.
The robotic shark. After creating the robotic fish, military scientists from the US Navy created a robot imitating the fiercest sea predator, which presents a sample of the shark robot. Like a real fish, this robot uses the tail to move and control its movements. It's 1 meter long and 62 centimeters wide. It weighs up to 60 kilograms. This robot moves similar to real sharks, so it is very difficult to distinguish it, or at least isolate it in the background of a real marine fauna. It can swim high up and dive deep, such as a real shark can, to an empty ship unnoticed, and it can spy, repair ships, and arrange sabotages. Guys, what do you think about it, and how will you use it? Let me know in the comments.
Number 8.
Festo Aracuda. The company Festo is famous for its robotic animals, and recently this company introduced their new son, the robot fish, Aracuda. The Aracuda is pneumatically driven. It follows its biological models in terms of design, shape, and kinematics. It has amazing muscles which provides its S-shaped movements. It allows copying the exact movements of a real fish. The device has liquid muscles, a creation patented by the company itself. These muscles have elastic holes made of rubber, as well as aramid fiber. Inside this robot, there is a swimming bladder, a special cavity that allows regulating the compressed air and setting the fish into motion. To use this mechanical fish for just 30 minutes, you'll need 400 liters of compressed air.
Number 7.
Robotic octopus. One of the most interesting robots is the octopus. It was made for investigating the deep bottom of the seas, and nowadays it is used exactly for that. Silicon tentacles are moved by electronic engines and accelerate the octopus up to 220 centimeters per second. This robot is equipped with camera and sound recording devices, and it was used for the first time in the sea to study French octopuses.
Number 6.
Salamandra robotica. This robot can move on the land and in the water. It can elegantly swim, similar to real reptiles. The Swiss researchers developed a model of salamander spinal cords and created a similar system to control the movements of their salamander robot. It receives electrical signals from a wireless laptop that can tell it to switch from swimming to walking, to changing speed or changing direction.
Number 5.
Soft robotic fish from MIT. It looks like a fish, moves like a fish, and even feels like a soft, real fish. The first self-contained autonomous soft robot, a fish that can execute an escape maneuver, convulsing its body to change direction in just 100 milliseconds, or as quickly as a real fish can. Their bodies are made out of soft silicone, and they can bend and twist because of that. They are also inherently safe to be around. And because of its body's capabilities to bend and twist, these robots are capable of very complicated motion and very rapid, agile maneuvers, which pushes the envelope on what machines can do today. Just like a biological fish, this fish also uses the escape maneuver or the C-turn to escape its prey. This soft robot might be more capable than hard robots in some tasks.
Number 4.
Festo Aqua Ray. Aqua Ray is a remote-controlled fish with a water hydraulic drive unit. Its form and kinematics are modeled on the movement patterns of the manta ray. The central drive and control unit of Aqua Ray takes the form of a festo fluidic muscle. This is combined with the fin ray effect, a design based on the functionality autonomy of a fish's fin that makes it possible to imitate the fin drive of the natural role model almost perfectly. As the Aqua Ray can be maneuvered extremely well, it can also be operated as both hydrostatic gliders with an active wing beat, substantial energy savings that can be achieved. Thanks to its shape and method of movement, the Aqua Ray can be used in wide-ranging areas of oceanography without disrupting the natural environment.
Number 3.
Festo Aqua Jelly. Jellyfish is one of the most beautiful and fascinating creations in the sea, and is the world of robotics too. Here, the company Festo introduced an autonomous and artificial jellyfish with an electric propulsion system and an intelligent mechanical system, which can adapt to any external changes. It consists of a translucent hemisphere and 8 tentacles with LED laser bodies. Inside of this bionic jellyfish, we can find a central motor of lithium-ion batteries and a navigation block with 2 servo motors to control the movements. This robotic jellyfish is able to calculate the power supply, and when the battery is running out of power, the device automatically sends the information to the charging base located on the surface and swims back up. This mechanical jellyfish uses a radio band, and when being underwater, it uses a system of infrared light for working the distance of about 3 feet. In the vicinity, the jellyfish can perform an evasive maneuver too. These jellyfish are so impressive and so cool.
Number 2.
Aqua Penguins. Like a real penguin, the aqua penguins have an energy-efficient and streamlined shape. Their wing propulsion enables them to maneuver autonomously in the tightest of spaces and even backwards. Aqua penguins can find their way in the water and move independently with the aid of a 3D sonar that mimics the real-life penguins. They can communicate with the world around them and with other bionic penguins. Aqua penguins can swim in groups without crashing by controlling depth pressure, temperature, and stability.
Number 1.
Eelloom Robot Snake. Meet Eelloom. This mechanical snake is designed to perform maintenance and repair operations on the seabed, mainly on oil platforms. This robotic sea snake makes no difference in underwater worlds. It is capable of replacing costly amounts of underwater vehicles easily, slipping into places where cumbersome robots cannot reach. It has cameras and sensors in both sides, and it has a modular design so that the different parts can be allocated for unique tasks. Developers of Eelloom suggested it will not only reduce the cost of maintenance under the sea, but it can also provide an easy way of carrying out regular tasks. Thank you for watching. Which one do you find the most impressive and useful, and why? Let me know in the comments. If you are new here, then show your love to the science world by subscribing to us. To get recent video notifications, press that bell icon. I'll catch you in another video. Peace!